Greetings, welcome to this new video about superposition theorem. Solve the problem number 6. In this video, I will demonstrate the application of the superposition method to solve a problem, and I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of 4 resistors labeled R1 through R4 as well as 2 independent voltage sources VA and VB and 1 independent current source IS. The question now is to calculate the current I through the resistor R2 using the superposition principle. Let's move on to the solution. First, we begin by identifying each independent source in this network. This step provides a clear understanding of the sources that will be analyzed separately. In this circuit, we can observe 3 independent sources, 2 independent voltage sources VA and VB, and 1 independent source IS. Next, we proceed to deactivate all but 1 independent source in the circuits. This involves replacing the inactive voltage sources with short circuits, which means zero voltage, and the current sources with an open circuit, which means a zero current. Let's begin by activating the independent voltage source VA and deactivating the independent current source IS and the independent voltage source VB, which will be replaced respectively by an open circuit and short circuit. The next step is to solve the circuits using conventional techniques. This circuit can be simplified as follows, where R134 is R3 plus R4 parallel to R1, which given by R3 plus R4 times R1 over R3 plus R4 plus R1. If we replace the resistors with their numerical values, we obtain R134 is equal to 3 ohms. The current I1 can be calculated by VA over R134 plus R2. If we replace VA, R2, and R134 with their numerical values, we obtain I1 is equal to 2 amps. Now let's consider the independent voltage source VB active and the independent voltage source VA and the independent current source IS inactive, which will be replaced respectively by short circuits and open circuits. In order to calculate the current I2, I will use the mesh analysis method. It's evident that we have here 2 meshes. This is mesh number 1 and this is mesh number 2. I will consider IA is the current in mesh 1 and IB is the current in mesh B. Let's start first with mesh 1. By applying Kirchhoff's current voltage law in mesh 1, we can write R1 IA minus IB plus R2 IA is equal to 0. If we replace the resistors with their numerical values, we obtain 7IA minus 4IB is equal to 0. Let's move on now to mesh 2. By applying Kirchhoff's voltage law in mesh 2, we can write R1 IB minus IA plus VB plus R4 plus R3 times IB is equal to 0. If we replace the resistor and the voltage with their numerical values, we obtain negative 4 IA plus 16 IB plus 24 is equal to 0. Now by performing 4 times 1 plus 2, we derive one equation in terms of IA. That means 24IA plus 24 is equal to 0. That means IA is equal to negative 1 amps. And from here, we can observe that I2 is equal to IA. That means I2 is equal to negative 1 amps. Let's move on now. We will consider IS, the independent current source IS, active, and the independent voltage source VA and VB inactive, and which will be replaced by a short circuit. In order to calculate the current I3, I will apply the nodal analysis method. In node 1, we can write V2 minus V1 over R3 is equal to V1 over R2 plus V1 over R1. If we replace the resistors with their numerical values and we continue simplifying this equation, we obtain 3V2 minus 10V1 is equal to 0. Let's move on now to node 2. By applying Kirchhoff's current law in node 2, we can write IS is equal to V2 minus V1 over R3 plus V2 minus 0 over R4. And if we replace the resistors with their numerical values and we continue simplifying this equation, we obtain negative 2V1 plus 3V2 minus 24 is equal to 0. Now, by performing 1 minus 2, we derive one equation in terms of V1. Finally, we obtain V1 is equal to 24 over 8 is equal to 3 volt. And according to Ohm's law, I3 is equal to V1 over R2. If we replace V1 and R2 with their numerical values, we obtain I3 is equal to 1 amps. After completing the analysis for each independent source while treating the others as turned off, the subsequent step is to combine the results algebraically. This process enables us to determine the overall circuit response. That means the current I is equal to I1 plus I2 plus I3. And if we replace I1, I2, I3 with their numerical values, we obtain finally I is equal to 2 amps. After we finish the calculation, we conduct a simulation using SPICE in order to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here is the independent voltage source VA, the independent voltage source VB, and the independent current source IS, the resistor R1, R2, R3, and R4. Let's move on to analysis. DC analysis, calculate nodal voltages. We can see here that I is equal to 2 amps. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves a validation of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about superposition method. Take care and bye-bye.